lot, maybe one or two. All right, let's get started. It says 2 children are selling lemonade. They are charging $1 for a cup. They sell only 10 cups. The graphs are shown. So now this is an interesting one because the x-axis or the x-coordinate represents the number of cups, and the the y-axis, I shouldn't say A, the y-axis, the up or down, is representing the number of profit. They make $1 or whatever it is. And so we're asked to figure out which graph represents that situation. Which one do you guys think it is? Why do you think it's A? That's the correct answer, but I'm curious, why do you think that it's A?
Because they're charging $1 a cup, and like every time it's charged, it goes up.
Yeah. And so essentially, it's not B because it's going to be the same amount. It's a constant rate of change, so it should be a straight line. Now, it's not D because the profit never changes no matter how many cups they sell. So as we go to the right this direction, that's more cups, we should have more profit. It should go up. So it's not this one. So it's either C or A. You guessed correctly with A, but the question is, well, and I think you're saying it, I'm going to say it a little more formal, a little more mathy. The reason that it's A is you're only going to sell 1 cup. You're only going to sell 2 cups. This continuous line implies that you can sell 1 cup, 2 cups, but also you could sell 1.5 cups. They probably aren't selling 1.5 cups for $1.50. They're probably selling 1 cup for $1, another cup for $1, another cup for $1. So it can't be C. It has to be A. Does that make sense? Yeah. Okay. So let's move on to the next question. So which one best represents this? Graph A. Which situations could be the other graph? Well, what would B be when they talk about the profit? So think of a scenario where you start making a lot of profit and then all of a sudden you don't make as much profit. No, you're still selling a certain number of cups, and I'm going to write it up here on the worksheet. So B could be, whoops, what did I do there? I went down a page. B could be your profit needs to taper off. So what could that be? Maybe you offer a discount what is it? 1, 2, 3, 4, 5 after 6 cups? Huh? Well, they're still selling them though, based on the graph, right? Well, the number of cups didn't drop. They're still selling them. The profit dropped. So so think about that. So for B, if you offer a discount after the 6th cup, in other words, you say the 7th cup is free. Or if you buy 6 cups, the 7th, 8th, we offer a 25% discount on, buy 6 cups, get 6 cups free. Buy 6 cups, get 4 cups free, whatever it is. But after the 6th cup, you could offer a discount. So what that means is you're still selling the cups, but your profit isn't going up. Does that make sense to you guys? Yeah. Sort of. It doesn't seem very practical from a business perspective. What could C be? Yeah. Yeah, real quick. C could be, you could buy partial cups. So you would say buy partial cups. So they say, well, can I buy 1.5 cups? Yeah. It costs this much. So you could sell partial cups. It could be self-serve. You could charge by the ounce, and there's 8 ounces in a cup. There's all kinds of scenarios for C. What about D? That could be a flat fee for unlimited cups. And it could be a partial cup too. So you've got unlimited lemonade. In other words, you might not fill up the cup. You might only fill it partially. You might fill it up all the way. Does that make sense? So for it to be a continuous line, you could have 1.1 cups. You could have 1.5 cups. You could have 1.3 cups. So that's how we do that. It says, is the graph that represents the given situation discrete or continuous? Is A continuous or discrete? No, opposite. This is discrete. Discrete graphs have dots. This is discrete. Continuous is a line. Continuous graphs, you never pick up the pencil. This is continuous. Because if I were to graph it, I'd put the pencil down and never leave it up. In order to graph this one, I'd have to lift it up, put another dot like this, lift my pencil up, put a dot, lift my pencil up, put a dot. Continuous, you don't lift your pencil up. I just draw the line, sort of. Does that make sense? And then what is D? Continuous or discrete? Continuous. I think I spelled continuous right. I misspelled the word infinitely. I spelled it infinite. I got infinitely and definitely confused in my mind. So discrete it is. Okay, moving on to the next one. It says a plane takes off and climbs steadily for 15 minutes until it reaches 30,000 feet. It travels an altitude for 2 hours until it descends to land, which takes 15 minutes at a constant rate. So we got to sketch a graph of this. So how do we do that? Let's try this. Let's draw our graph. This is our y-axis. And this is our x-axis. And this represents the time. This represents the altitude. So let's go through. It says it takes off. Where's it taking off from? The ground. And it reaches and climbs steadily for 15 minutes until it reaches 30,000 feet. So let's call this 30,000 feet. And let's call this 15 minutes. Actually, that's a little too far out, actually. I'm going to run out of space. So we'll call this 15 minutes. So in 15 minutes, it goes from 0 feet to 30,000 feet. Okay? Let me redo that so it's straight. So it goes from here to here in 15 minutes. So then it travels at that altitude for 2 hours. So for 2 hours, it just stays at that height. Okay? And so over here, this would be like 2 hours and 15 minutes, right? And that's the 2 hours plus the 15 minutes. So then after that, it descends to land, which takes 15 minutes. So another 15 minutes. So from here to here, it goes back down to the ground. That's the graph. Is that discrete or continuous? No, that's continuous. Do you see a bunch of dots? Now, I had to lift the pencil because I'm teaching you how to do it, but if I wanted to draw this graph, I'd put the pencil down and just draw it in all one thing. What's the domain? Well, the domain is the x value. So I've got 15 minutes here, I've got another 15 minutes here, and then 2 hours. So the domain is from 0 to, how many minutes are there in 2.5 hours? 120 plus 30, so I would say 150 minutes. Okay? Because you got 15 minutes here, then you got in other words, this is 15 minutes, this is 120 minutes, and then from here to here is 15 minutes. Okay? Now the range are the y values, so the range goes from 0, and you can include these values too, 0 to 30,000 feet. Okay? Any questions on that? I probably should look at my little teacher book and see if I'm doing it correctly. Now the textbook says I did it in minutes, but if you were to do this in hours, it could be 0 to 2.5 hours. The range is the same though. Okay. All right, let's sketch out this graph. Down here it says a contestant on a game show is given $100 and asked 5 questions. The contestant loses $20 for every wrong answer. Well, now how does that look? All right, so let's draw our graph first. So I'm going to draw the graph. And then it's not perfect. And the y value is how much money you have. The x value represents the number of questions. We start off with $100, and then we're going to lose 20, 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 and then ultimately it would be at 0. And it says the contestant loses $20 for every wrong answer. So you start off here, and then you end up here, then here, then here, then here, and then ultimately here. Is that discrete or continuous? That's discrete. Now what's the domain? The domain is the x value. So x goes from 0 to 5, right? And then what's the range? Well, it goes from 0 to 100. Let me write that out so you guys know. This is the domain. This is the range. Same thing over here. The domain refers to the x values, and the range refers to the y values. Okay, we're almost done with this paper. We got 2 more questions. I'll give you a second to write that down. Actually, 3 more questions. Okay. Let me know when you have everything sketched out. Okay, we're almost done. Hang in there. We got to hurry, though. It says you decide to climb a mountain, and, well, I know they're going to ask us to graph. So let me just draw the graph, and I'll try to sketch it as we continue along our That's close. I'm trying to get it at 90, but it's really hard to do. All right, so it says you climb steadily for 2 hours. What does that look like? Well, I'm just going to climb steadily for 2 hours. Then you take a 30-minute break for lunch. Do you go any higher? No. So you just kind of like that. You don't go any higher. You don't go any lower. Then you climb faster than before. And when you reach the summit, then you enjoy the view for an hour. So that's twice as far this way. Hold on, let me get this. I want it to. So then you go this way for twice as long. And then you then you start to descend. You climb down the mountain. It says here you take a little bit of a break. And then you climb down the rest of the mountain. That's the graph. Is that discrete or continuous?
Continuous.
Yeah, that's continuous. All right, so now it says, what's the possible situation here? Well, you've got a distance. How about you are visiting a friend and you walk home. So that's this. You're starting to walk home, and then right here at point A. So this is A. This is segment A. I'm going to put the A here. Then for B, you slow down a little. So let me just erase this, and I'll just put the A segments here. So this is A, this is B. C, you rest for a minute. So this is C. D, continue home. That's D. E, what are you doing at E right here? Yep, you're going to rest for a minute. And then lastly, F, walk completely home. See how that works? And that would be F. Does that make sense to you guys? Did you have a question, or were you just like, oh, I'm done, and you want to throw your pencil down? Yep. Yep? He said, yep. Well, which is it?